Good afternoon, fifth period. How you doing?
Good.
So you see how my song fit the theme of the day, what we're going to be doing? It's all about the signs. All right, so make sure that you have a superhero out. So if you haven't gotten one, please head to the base. Pick up your favorite hero. We're going to be doing a lot with decimals today. And you're going to need the calculator to help you get those decimals. So let's start off the day with a recall, our upside down question mark for recall. And I'd like you guys to please recall from Friday's lecture notes. So if you happen to have those out, you may want to get them. And look up for me the ratio you use to determine the sine of an angle given a right triangle. So I need that ratio from Friday.
What?
The ratio for sine.
For sine?
Mm-hmm.
What do you mean?
When you're given a right triangle, which sides do you use for sine? So if you look on the right-hand side of the paper. Yeah, no,
The opposite and the J.
yeah, hypotenuse for
Oh,
sine.
yeah.
These. This was the ratio. Hypotenuse. I totally misspelled hypotenuse, sorry. So as you're starting to get to work with these trig ratios and these trig functions, you want to start having in your mind this whole SOHCAHTOA thing. Okay? So start having that in your head as a way to help you remember sine goes with opposite and hypotenuse. All right. Let's get on with the first example for today. First example is going to come to you from your blue book, page 139. It's not any specific question. We're going to make it up, but it's going to be similar to what you see in your blue book. So if you'll please draw for me a right triangle. You can make him pretty big if you want to. Whatever makes you happiest. Mark your right angle. I need 3 letters to name this triangle. C, A, and L is what I heard. I need 3 numbers for the side lengths of this triangle. 2, 3,
7.
and 7. All right, I don't know anything about these numbers, whether they are going to make this beautiful right triangle or not, but we're going to say it does. All right, and the directions for this particular section is going to say, find the sine of L and the sine of A. Write as a fraction and decimal to 4 places. Okay? Now the numbers and the letters on some of them are different. All right. I'd like you to please take this leftover space that you have here on the right side of your triangle. If you have more than a couple inches, okay? If you've only got like this much space, right under the triangle. But if you've got quite a bit of space, I'd like you to please take your paper and fold it over a little bit so that you see just the triangle. And this will give us a crease so that we can run 2 things at the same time. Okay? All right, so the first, I'll put a little line there for myself so I don't go past it. The first one says the sine of L. Well, L is our angle, this angle in particular. The sine of any angle is found by the opposite over the hypotenuse. That's what we recalled from Friday. So set up the sine of A over here in a similar fashion. Notice how I'm abbreviating the name of the sides right now. You can take your highlighter and highlight under it so that way you can see. All right, sine of L. We need to find the measure of the side opposite angle L. Here's a really great trick if you're having trouble figuring out which side is which. Take a pen or a pencil or a marker and cover the angle that you're looking for. In this case, I'm going to cover L because I'm looking for the sine of L. And make sure the point of your marker, your pencil, or your pen is pointing into the triangle. Whatever side that looks like it's pointing at is the side opposite that angle. So then the opposite side is 3. The hypotenuse, you can use the same trick, but make sure you cover the right angle. That'll point to your hypotenuse. Okay, use the same trick to do the sine of A. Do that right now. If you're following on YouTube, pause it right now to watch, to try it. I meant. All right, so what fraction did you get over here for the sine of A? 2 over what was it? 7. Yes, lovely. Because if I cover the A, I'm pointing at the 2. And if I cover the right angle, I'm pointing at the 7. Nicely done. All right, we have it in fraction form. Is it in simplest terms?
Yes.
Yes, so I don't need to do any kind of reducing. I'm done with that, but I also need it as a decimal to 4 places. So go to your superhero, type in 3 divided by 7, but please make sure that you do Control Enter, otherwise it'll just give you the fraction again.
1.4285.
285. Lovely. I also need the sine of A, same thing. 28571. 74. Okay, we're only going to 4 decimal places, so we'll stop there at the 7. All right. Any concerns or confusions or questions that you have about this right now? Thumbs up, this feels really good. Thumbs sideways, you think you got it, but you're definitely going to use your notes. Thumbs down, you're completely lost. Vote now. Okay, so I've got a few thumbs sideways, no thumbs down. Good job for me. I'll pat myself on the back on that one. Means I explained it really well, yeah? Yeah? Thank you for the nod. All right, let's go on with the next example. Next example is coming to us, and the last example for the day is coming to us from page 140. Question number 13. I'm going to change the directions, the way they read a little bit, so that it's specific to what we're doing today. These directions are going to be asking you to use sine and cosine. We're working on just sine today. So I'm changing your directions a little bit from page 140 to say use the sine to find the variables. I'd like you to draw a nice big triangle for me. You can make it as big or the same size as the one before. Mark your right angle. Mark your side lengths as I have. Bless you. Mark your angle measure as I have. I'm going to zoom it in. I'm going to take a moment up here. I'm going to write A and I'm going to write B. We're going to try to find them both using just the sine function. Let's remind ourselves of how we find the sine of some angle. The sine of some angle is found by the And what was the other one? Hypotenuse. Yes, indeed. If you don't have these memorized yet, that's okay. Go to your notes from Friday. Okay. Now, down here, I've got to figure out which angle do I use. Well, right now, which angle is the only angle I have information about?
That one.
This one. Remember that this theta, this symbol theta, represents the measure of whatever angle we're talking about. So if I already know the measure for this angle, I can write that the sine of 57 degrees equals the side opposite it divided by the hypotenuse. And I'm going to get an equation that looks a little something like this. Which is all well and good, but you're sitting there going, I know, right? It's almost like I've got it down to the, I really don't. I really don't. You're wondering, I'm sure, how do I do this thing? Right? How do I figure out what this is? Go to your superhero. Hello, superhero. I'm using Carol Ferris.
I don't know who that is.
You don't know who that is?
Wow, for a big old-
Okay, if you're not sure which hero you have, because you have their secret identities here, flip them over and you should see their hero name on the back.
Oh.
So, I'm using Star Sapphire.
I don't like Superman.
You don't like Superman? I've got, that's okay, he's an acquired taste. I have Richard Grayson.
Hey, that's your actual name.
Oh, it's Superwoman! It's not even, depending on which story you go with, she's an evil villain.
Wait, is this Superman?
Yeah, Superwoman. Lois Lane, Superwoman. You should check out the, oh, I don't remember the name of the series. Oh, I was just researching it last night. No, it wasn't Smallville. She's a character from Smallville, but this particular Lois Lane variant, named Superwoman, could have been a villain from the, I don't remember the name of the storyline. I'm going to go crazy. I'll find it. After lecture, I'll find it and I'll tell you. Okay, so come here with me, please. Go to the home screen, and we're going to check to make sure the calculator is set in degree mode. Go to Settings, go to Document Settings, and make sure that the little box by the word angle says degree. If it doesn't, change it, and as soon as it says degree and you've saved it, please give yourself a pat on the back and say, I'm awesome.
Where did you want
I'm
it?
awesome. The angle needs to say degree.
Oh, okay.
All right. Once it does, go to a new document. Don't save the work that we were doing last class period. Add a calculator page. And I need you to find the trig button. It's located just to the left of the number 7, right next to control. And when you push it, you're going to see this little menu appear. Notice how it's already got the 3 trig functions that we've already started talking about. Sine, cosine, and tangent. It also has these other weird ones whose names I'll give you later. You study them more in Algebra 2, college algebra, pre-cal, that kind of thing. We're not going to be using these. One more time. The trig button next to the 7. We're not going to be using these. We're going to be sticking to these first 6. We're using the first 6. The top 3 are the ones we're familiar with. And is anyone wondering what this, they have a -1. What does that mean? Right? Okay, so here's what this is. You notice how sometimes I was calling them the trig ratios and making them fractions? And then today I started talking about them as functions. I need you to find the trig function button, right? Well, just like with operations like addition or subtraction, multiplication or division, in math, not only can you undo operations, but you can undo functions. Because functions are just a whole bunch of operations, addition or subtraction or whatever, all mashed together to do something to a number. And you can undo them. This is the notation we're going to use when we say that we want to undo whatever it is that sine does to a number to give us the value for this one. We'll play with it later, but that's what that is, and we're going to use them a little bit in this class. So go ahead and select the sine function for me, please. and type in the degree measure of the angle we're looking at, and we get this number. This is not the answer to the question. This is not the answer to the problem. This is the value of the sine of 57 degrees. Okay?
Ah, I get it.
If you had an I got it moment, remind yourself up here to the left what it was that you got right here. If you're worried that you're going to forget later, write yourself a quick note. The sine of 57 degrees is getting replaced with this decimal number. Now that we've done this, we have an equation with fractions. How do we handle equations with fractions?
Multiply.
One more time?
Multiply.
Multiply by what?
The answer to the numerator.
The answer to the numerator. The number that goes with the numerator?
Yes.
The denominator?
Denominator.
Awesome. Why are we multiplying by the denominator? What will that do for us?
Fraction.
To get rid of the fraction. Lovely work. You can totally multiply by the denominator, or you can turn this into 1 fraction equals 1 fraction and cross multiply. Either one is right, and you do whichever one makes you happiest. Okay? Because we've been doing proportions lately, we were doing those similar figures, I'm going to do the work for cross multiplication, just to give you another example on how to see it. So I'm going to multiply these two numbers together.
Yes, I got my answer.
You got your answer already. You are fast. I'm going to multiply those together.
This is the same thing as doing just multiply b.
Say that again?
It's the same thing as just doing multiply b on both sides.
Yes, it's exactly the same as multiplying b to both sides. Yes, you're right.
I'm still confused on the thing.
On where?
I was supposed to be cross multiplying.
Yeah, we're cross multiplying.
I go with dividing and you still multiplying.
Right here, we've done our cross multiplication, and now we're going to do the next thing, which you had said was divide.
Yeah.
Because what's happening here between this big decimal number and b?
You gotta divide by 14.
Well, I got
You guys divide by 0.8387.
Yeah, we have to actually divide by the 0.8387 because that is what's being multiplied to b, and I want to get b all by itself.
Yes, I got it.
What is it?
16.7322.
322. Can I get some confirmation, please? Remember-
16.69.
16.69.
Well, mine is right.
Okay, both double check, and I need some other confirmations.
I
836 8387.
Wait, what?
It's 16.69. Yeah, 16.69. Oh, yeah. I forgot an 8.
Okay, forgot an 8, no problem. All right, so there's B. I'm going to zoom out just a little bit.
I'm smart.
You are. Now, we've been asked to find the value of the variables. We need to find A also. But if we use this angle measure, we're not going to be able to do it using sine. But if I use this angle right here, I can use sine because it'll give me the opposite over the hypotenuse. I don't know the angle measure for this, but do I have enough information to find it?
Yeah.
All right, give it to me.
Oh, 16 14. I mean, 16 14, yeah.
Right here. I need this angle measure.
Did you add 90 and 57?
Add 90 and 57 together
Just subtract 180.
and subtract it from 180. Fantastic, using your triangle angle sum. So what's my angle measure?
I got 33.
33, and that came out from like 3 different people, so we'll take it. So the sine of 33 degrees is equal to the side opposite the 33 degree angle, divided by the hypotenuse, which we just calculated. You see the similarities already? Go find me the sine of 33 degrees. Go to your trig functions on your calculator. 0.5546. 0.554.
544,639.
6. Okay, we'll stop there. So that's A, 16.69. Again, we have an equation with fractions. We could cross multiply, but notice how here we had a letter, and so it was kind of hard to think of multiplying everything by the denominator. Here they're just numbers. So let's see what it looks like when we just multiply everything by the denominator. Okay, we're real ugly there. Someone help me with this multiplication. 16.69 times.
I got 9.09.
9.08937.
Huh? I got 9.09.
9.08937.
All right, so we're just going to round this guy. 9.0894. All right, looks pretty good. Tomorrow, we're going to look at this again, the exact same triangle, but we're going to look at it from cosine's point of view. Okay, and we're going to be calculating the same values, but using cosine. We should end up with the same answers, and it's going to be a very similar process, but we're going to be using the cosine function instead of the sine. That's it.